All right. Good morning, everybody. Welcome back to COM 2452, Software Development 2. I don't know about all of you, but I've noticed that it is like getting brighter out earlier and staying brighter for longer. And the forecast is, at least as far as I can see, doesn't have any 20 below readings in the future. So like spring's coming and I'm looking forward to that. I hope that you have all had a great weekend. This week, we're going to spend some time thinking about a couple of different topics. I want to wrap up thinking about security, and our foray into security has been pretty brief, but that's all that we really wanted to cover in this course is the brief stuff that we're talking about in terms of security and kind of thinking about the kinds of data that you could have in an application, like in an application in general or in a database. On Thursday, we'll spend some time taking a look at the implementation rubrics for our phase 2 submission. The security stuff that we're talking about today, and very specifically the idea of hashing passwords, that's kind of the end of the implementation of phase 2 stuff. So anything that we start talking about after today's class is going to be for phase 3 related stuff. What I do want to do today is, what I want you to be able to do by the end of today's lecture is, I still want you to be able to use tools such as prepared statements to prevent SQL injection attacks. I want to spend a little bit of time today going through what we did last week. And so this is going to be kind of stepping through, like, I'm going to bring up our web server and look at the application in our browser and like click on buttons. And what flow are we actually taking through all of this? And kind of get to the point of formalizing this idea of prepared statements. So what did we actually do in the code to solve this problem? And then very generally, how do prepared statements actually protect us against SQL injection attacks? So how is this different from just doing string templates? What have we accomplished by using these prepared statements? After that, I want to spend some time again. We had a rapid introduction to this at the end of class last week, and so I want to spend more time on this. I want to be able to begin to identify the kinds of risks associated with storing user data or information. And so at this point, I'm going to be asking you for some feedback. I want to know what kinds of data, just in general, apps might have about their users. So I'll broadly be asking you this question to get you some feedback, get some feedback from you, but then also, what are the consequences of releasing that information? Like, we don't really plan, I don't plan to release sensitive user information to the wild, but what happens when that information does get out? So what are the consequences or the risks attached to actually keeping that data in our database? I want you to be able to securely represent and store credentials for authentication purposes. So again, we're going to dwell a little bit on the idea of hashing passwords. I'm going to strongly recommend that you use a specific tool for hashing, and then we're going to define some of the terms that are related to this idea of that specific hashing algorithm, but then also just hashing in general. So the words that are going to show up here are things like salt. Salting passwords is something that's an important part of protecting against certain classes of attacks against passwords cracking. So let's take a look at the current state of our project to get a sense of a couple of different things. How do we get from main.ts? And this part is going to be moving a little bit more quickly because we've kind of stepped through this. I'm not going to talk about binding buttons to behaviors anymore. This is going to be focusing purely on the flow of like how we're interacting with our database and the idea of asynchronous execution of JavaScript stuff. So how do we get from main.ts to having teams of Pokemon showing up on the page? And I also want to think about and take a look specifically at the prepared statements that we added. So how do we foil Red Team Walter? How do we stop Red Team Walter from injecting SQL into our SQL so that he could effectively take over the team of Pokemon that we've got here? So I'm going to pop over to my terminal here. Is that big enough for you to see at the back okay? Okay, awesome, thank you. I want to spend a little bit of time taking a look at the kind of start of execution from where we're beginning with this app. And so I'm going to go to my web browser to start. I don't think I have formally shown this in class, so I do want to demonstrate this to you in class so you can see this happening. But I want to get this app back to like completely new state. And so in class, I have demonstrated this idea of dropping the tables in my REPL. But I want to go even further than that. I want to fully delete the database. I want to start fully from scratch so that I don't have any kind of lingering side effects left over from interacting with my application. So I'm doing this in Firefox, but there are similar tabs that you can find in Safari and Chrome to accomplish the same tasks. In Firefox, to find the storage location for our database, there's a storage tab in the developer console here. Forgive me, I forget what it is in Safari, but I think in Chrome there's an applications tab or an application tab that you can find this. Regardless of what it's called in Safari and Chrome, the thing that you're looking for is something that is file storage, and really specifically it's this indexed DB thing. So IndexedDB, if you remember when we're setting up our connection here, I'm going to go back to our code here for a second, and I'm going to open up connection.ts. When we're setting up our connection here, we're using this IDB : / prefix. This says I want you to use this IndexedDB technology under the hood to store my database. And so we're looking specifically for this IndexedDB thing. And then beneath this, what we're able to see is this is actually the database. This is not human readable. This is a mess. These are actually arrays of numbers that really represent the internal state of the database. This is binary data that represents the internal state of the database. We're not meant to read this, but we do want to be able to get rid of it. And so if I right-click on this and delete this, and then I refresh this page, we're starting from scratch again. I've fully, completely destroyed the database here. I'm starting all from scratch. All of my tables have been recreated. There is no database. The sequence numbers of our serial columns are going to start at 1 again because we've blown everything away here. When you're dropping the tables, you might have noticed if you're working with serial that it doesn't always start at 1 again. It kind of just starts wherever it left off. Fully deleting the tables here and fully deleting the database will cause it to start from scratch again. So we're going to start all the way back down at 1. All right, so I'm going to close this. And the state that we're in, I'm going to go back to my terminal here. The state that we're in is that we have initialized our trainer controller. So we're in main.ts. We've loaded our index up, and we're starting to execute code in main.ts. We've launched, we created an instance of the trainer controller. I'm going to open that up. And the trainer controller is going through its constructor. And in the trainer controller's constructor, we're asking for all instances of trainers because we want to be able to either prompt to show, I want you to make a new trainer in the database, or I want to show this existing trainer that's already been put into the database. So the first thing we're running here is on line 18. We're asking for all trainers to come back from the trainer domain model instance, from the trainer class, sorry. I'm going to open that up. In the trainer class, we're asking for get all trainers. So that's this method right here. This is an async method. And so this is that whole JavaScript concurrency thing. In JavaScript, though, remember exactly one thing can happen at a time. There really isn't multiple things happening at a time. We're just taking this work and kind of shoving it off to the side. So in our trainer controller on line 18, we're asking to get all trainers. We do start running code here, but as soon as we hit this await line, this is that operation that basically just says, all right, take this work, just shove it off to the side and go back to where you were before. Going back to where we were before is here on line 18. We proceed then to line 21. And this is one of those circumstances where I need that result. And so we're going to have to take that queue of work that's been pushed off to the side, find the thing that we're waiting for and dequeue it so that it will actually run. So The dot then part here is very specifically, this is me taking that promise and saying, I need the results from that. So only after I get the results from that promise am I going to start running this code in my trainer controller. That then takes us back here. And here's where we're starting to do that selection. I want to get all those trainers back, and we're going to actually wait for that to happen now. Once we do that, we're going to keep going in the trainer class itself, in this static method, and we're going to iterate over the rows that came back from that. This is going to allow us to iterate over the array of trainers that we get back. We got trainer names. We're constructing each trainer instance for each of those rows that came back from the database. And then on line 43, we're hitting another await line here. Await says, take the state that we're at, push it off to the side, and kind of go back to where you were before. At this point, the place where we were before is on line 21 in our trainer controller. We're still waiting for this to finish. So we still are stuck on this dot then, and that kind of means that we pushed work off to the side, and we're just immediately going to un-dequeue that and go back to that work. We're still waiting for that promise to finish. So the promise here is going to get Pokemon for trainer. I'm going to open up my Pokemon class here. In the Pokemon class, we have this static async method, get for trainer. The very first thing we're doing in this is issuing a query, await for this. This enqueues some work. This takes us immediately back to the trainer class here. In the trainer class, we're awaiting for this. We're going to go back to the thing that we were at before. We're in the dot then here. It's still waiting for all this to happen. So we kind of like enqueue this work and dequeue it a bunch of times, and we just kind of go back to that same state again. So that takes us here. The query that we're running here is now a parameterized query or a prepared statement. And the question that we are asking is, I'd like to get some information from the Pokemon table. So that's this one. I'm asking for Pokemon table entries for specific conditions. So where trainer is equal to, and this is one of the placeholders that we've inserted here. So this is that $sign for a parameterized query. The $sign says, look in the array that I'm passing to you beside this. So separate from that, I'll come to you in just a second. Separate from that, and I want you to take that value and eventually, at the database level itself, insert it into the query that we're running here. But we're asking for the ID of the Pokemon. This is that synthetic key. The nickname, this is something that we've inserted before. The HP, this is something we've inserted before. And the trainer. And this is the foreign key that we have back to the trainer table for this Pokemon. Yeah. Yes. Is that big enough for you? Okay, awesome. All right. The parameterized query that we've added here is still using that .query method to get data from the database. So we're still calling .query. And then with pglite and TypeScript in the angle brackets here, what we're doing is describing the shape of the data that's coming back to us. So I'm selecting 4 fields from this. I could also have done select star because this really is all of the fields on this Pokemon table. But this describes the shape of that data. So the ID value that we get back is a number, the nickname that we get back is a string, the HP is a number, and the trainer that we're getting back here is a string. So we then queued this work. We got all the way back to the .then. We then proceeded back to this work that we're waiting for because we're just stuck waiting for this. And at least in this case, on the page as we've just loaded it, there are no Pokemon. And so we get no rows back from this. There's nothing that matches this query because there's nothing in the database right now. So we're going to go back and return all Pokemon. We go back to this trainer class. And in the trainer class, we're going to do nothing because we don't have anything to push onto this. And then ultimately, we're going to return this empty array. There are no trainers in the database. There are no Pokemon for any of the trainers that we have here. At this point, the .then runs. We've finished running this work that we pushed aside and asked to execute later. And so we return back to our controller. The controller is now able to use this array that's been returned from that promise. And in this case, the length of the trainer's array is 0. And what we're doing is initializing this create trainer view. So when we get to our page, this is what's showing up here right now. The end of execution here is we kind of just run off the end of this constructor. We go back to main, and there's nothing left for us to do. So at this point, if there were other enqueued work from the await statements that we have executed, this is when it would start to happen. At this point in the page, nothing is happening. There's no JavaScript code or TypeScript code that's actually running right now. We're just kind of sitting in this state waiting for us to start interacting with it to do stuff. And so at this point, I'm going to start typing some stuff in here. And it's only when I release this button, so clicking on it right now has not done anything, but when I release this button, is code actually going to start to execute for us. I'm going to move my mouse off of this so that I don't release yet, but when I release from this button, what's going to execute is our add trainer methods. So this is in the trainer controller itself. We're going to create this new instance of trainer. So our controller has the responsibility of creating this domain model object given input from our view class. We're going to invoke the save trainer methods in the trainer class. But in this save trainer class and in the context of our controller, we don't actually care about the results of this query. So what happens here is I click on that add trainer button. I release it. It takes the name that I've passed into it. It constructs this new instance of trainer. We're calling the save trainer method on the trainer class. We start executing code here in the save trainer class. We get to this await statement. We push this work off to the side, and we go back to where we were before. Where we were before is in this add trainer method, and we proceed. We remove this create trainer view. It's removing itself as part of that button click, but we're also uninitializing it in the context of this controller, so we're removing that state. And we're creating a new view for this. I've just created this trainer, and so I want to show the trainer on the page. That will render the rest of this stuff, so it's got a list of Pokemon, it's got the buttons that we can interact with. After I finish this method, we're kind of back into that state of there's nothing happening. The page is just in this inert state waiting for us to do stuff. And it's at this point that we will dequeue that work. So that work that we pushed off to the side in the save trainer with this await, it's at this point that we come back to this work. And we will now go through that process of inserting into trainer. This has that on conflict cause clause in it, so do nothing. If you have this insert failure, just don't do anything. Just like give me a thumbs up and keep going. I know that I'm going to keep saving this over and over and over again with that same natural key, but I don't care if there are key conflicts because I don't really want to worry about that in the context of this. I want to keep saving the same trainer over and over again. The returning part here, this is a way for us to get that synthetic key back, but we're also using it here to just give another example of that happening. It doesn't actually have any effects here. So on conflict, do nothing, but we're also using these parameterized queries. I'll come to you in just a second. We're using these parameterized or prepared statements here. So insert into trainer values $1, and then we're passing this separate array that has just the name in it. So we're separating out the query itself, the thing that's doing the insertion, and the actual data that we're inserting into it. And now we know that they are two separate things. The value that I'm inserting into this, this column for our trainer table, when it gets to my database, I know that that's actually not part of the query. And so my database is then able to do stuff with that so that it's able to just put that value into the column. Yeah.
We push this to the queue and then come back later, right?
Yes.
Update some information in trainer about the trainer, like the name or something. Which one would we see? The initial name when we push that to the queue, or the updated one?
If we updated the name of the trainer, in what context?
Like if the trainer name was updated after we pushed this to the queue, like to save it later at the end of the process?
So I guess, so the question is about updating the trainer name. I guess the context here is that we don't even have that functionality right now. But another problem with that is that updating the name as an operation is going to be more complex than just saving this, because the name of the trainer is our natural key right now. And so if I change the name of the trainer, I actually have to go through and change all the foreign keys that refer to this same trainer. To your question though, if I were to do that, this is a queue that I'm pushing stuff off to the side. So I would enqueue work here, and then if some other operation also ran concurrently, so it wanted to update the name of the trainer, it would be enqueued as well. So it would kind of be stuck behind that in this case. This is a FIFO, so this is first in, first out queue. The first thing that gets inserted here is going to be the first thing that comes off, and so that first one is going to be this insert operation. Yeah.
Probably being like information about like the row that is referenced, like exactly that column is referenced by other rows. There is no such thing as like cascading, so that the other rows know that the thing they refer to has changed and they change themselves.
That's right. So there's no way for us to have necessarily like a modification that's going to affect many different rows all at the same time. There are ways to accomplish this, but this is an operation that you really shouldn't need to worry about in your applications right now. The way that you'd accomplish this is to turn off foreign key constraints, which is not something you want to do. Turn them off, make all the changes, and then turn your foreign key constraints back on again. This also leads back to that keyword transactions that I said we weren't going to talk about. And I think we will talk about it, but later. It's not something that's critically important now. Yeah. The view should not directly interact with the database, no. The view should only really interact with the database kind of through the domain model instances. So the domain model instances will have accessors, and the views are welcome to call those accessors, and the accessors themselves might interact with the database, but the view shouldn't have any SQL code in it. The way that we're making the view wait is effectively by doing stuff like this. So when I say .then on this promise and only then start creating instances of view classes, that's me saying you have to wait for the results from the database before the view can do anything with that. In this case, the create trainer view is removed entirely. So that's the modal dialog that shows up on the page. So that one, it continues to run, I guess, in the sense that it removes itself from the page, but it doesn't really exist after that. In this one, the trainer view does start to do stuff, but we have all the information that's necessary. If I wanted to say, I can only show this, so I can only show this because I'm waiting for the database to generate a synthetic key, for example, and I need that synthetic key to show up on my page for some reason, this is when I would say things like .then, and then I put the construction of that view in the .then part of this promise. In this case, this is a contrived example. The only thing that we're showing about the trainer on the page right now is their name, and we have that information already, so I don't have to wait for the database to fully insert it for me to be able to do that. It should only really disappear once you know you can cause it to disappear. That kind of. But again, this would be a .then operation. Yeah, so like you would say .then do this if you get something back from your user account selection. Yeah. Okay, so we push this work off to the side. We're kind of in the state that the view has finished changing itself. We've got the trainer view is showing up on the page, and we're sitting in this inert state. Now what we're going to do is insert that. The trainer as we have it right now does not have any Pokemons because we've just created this trainer instance. So we're going to skip over this loop. We're going to return this trainer. but it's not going to really return to anything. We've dequeued this work, and there's nothing waiting around for the results of this. So we're just going to end this method at this point. At that point, we're going to be in this state. So our view has shown up, and we're going to be sitting around. If there's other work that has been enqueued, this is a place where that other work will happen. We're sitting around and doing nothing. There's no work that's currently happening right now, so we're going to drain or empty out the queue of work that we otherwise have, and there isn't any right now. When I click this Add Pokemon button, there is no internal interaction here. This is just causing that dialog to show up. I'm not doing any modifications to anything yet. But here is where I'm going to be able to do things like create the Pokemon name that I've got. And it's when I click and release this button that we're going to start to interact with our database again. So with our trainer view, that's going to take us up to, whoops. With our trainer view, that's going to take us to this add to team method. So when I click and release this button, it's going to get those inputs that are being provided by the view itself, create an instance of the Pokemon class. And remember, we made this modification that we've added that bidirectional relationship so that we can have a reference to the owning trainer. And here is where we're going to start interacting with our database again. So we're going to say this.trainer.addToTeam. This takes us back to the trainer class itself. Adding to the team here is a push operation. We're making changes to the internal state of this trainer class, and then we're saving it again. I'm going to skip over all the save part of this, but this does push work off to the side. We go back to the add to team method in the trainer class itself here. We notify all, we return back to the controller, we remove that create Pokemon view. It shows back on the page that the change was made to the array of Pokemon that are on this trainer. And then we're going to take this work off. So we've awaited here on this insertion statement. On conflict, do nothing. There is a foreign key or a duplicate key constraint that's going to happen here, but we're just going to skip past it. And now for each of the Pokemon, we're going to cause each Pokemon to be saved. I'm going to go to the Pokemon class here, and we're going to save the Pokemon. So saving the Pokemon here is up. We're inserting into our Pokemon table. This is where we're doing things like getting the ID back. So I'm inserting into my Pokemon table some values. I'm inserting an ID, a nickname, the HP, and the trainer. The ID field, or the ID column, this is my synthetic key. And so I'm using this default value to say, database, please just insert whatever it was that you were going to insert. And then for the remainder of these columns, 1, 2, and 3 here, I want you to use the data that I'm passing to you in this array separately. So it's going to take the nickname, the HP, and the trainer's name from the separate array that I'm passing alongside this. Once we get data back from that, we iterate over it, we modify the Pokemon itself to initialize that ID, that synthetic key that we got back from the database. We return these Pokemon, but just like before, we're returning to nothing here. Nothing's waiting for us to finish. We're just going to return the data. We're going to finish this method, and we're kind of going to be back into the state of we've got this page that's sitting here and there's nothing happening anymore. I'm going to do one last thing here, and that is I'm going to insert some value into this that is going to have what was previously a SQL injection. So we're going to pretend that Walter is taking over my database again here by inserting something into my database. And when I click Add Pokemon here, this is consistent with what we saw before, but the difference now is going to be that when I refresh this page, the name stays the same. And so the difference that we've got here is that when I've saved this Pokemon, by using this prepared statement or this parameterized query, The name of the Pokemon is going to be passed to this query, kind of beside the query that we've got. So I'm saying insert into Pokemon ID, nickname, HP, and trainer. The ID value is default. This is a synthetic key. I want you, database, to generate this value for me. I'm passing the values or placeholders here, 1, 2, and 3, to say these are values that will get inserted into, but the database is going to receive these two things as two separate pieces of data. One is the query itself, and the database will take that query, and it's internally going to start parsing stuff. It's going to do things with that query to build its own internal state that represents something that it will be able to use to insert values into its table structures. And then once it's done that, so it's done all the operations it needs to do on the query itself, it will then take these values and inject those values into its own internal structure. It's already gone through the process of parsing SQL at this point, and injecting these values into its own internal structure that represents what this query is supposed to do means that it knows that whatever we've typed into this nickname field, this is data, and it's not runnable SQL code. It's not going to treat it as runnable SQL code because it's explicitly separated from this structure that we have, from the query statement that we've got here. All right. I'm going to pause here for a moment. This was boring as hell, but we now have a pretty solid view, pun intended, I hope, of like how we get from clicking on buttons to inserting data into the database and then coming back from all of that again. I'm going to pause here for a moment to catch my breath, drink some water, and see if you have any questions. Yeah.
Actually having a cyclical relationship with trainer and Pokemon in our code, isn't it like really desirable to have something like that? Or
In what way do you mean a cyclical relationship?
So like a trainer has a reference to a Pokemon in our code.
Yes.
A Pokemon has a reference to a trainer.
Right.
Like so one class kind of depends on the other, but the other depends on the first, sort of. And I was thinking about kind of replacing the trainer field for Pokemon with trainer ID, just with like a alpha.
So your question, I think I'm going to go up here. Your question is kind of about the relationship that we have right now between Pokemon and trainers, where we have this team of Pokemon that's an array of Pokemon, and we have a trainer that's the corresponding owning instance of trainer that's attached to this Pokemon. Having this relationship that goes back and forth is kind of fine. Yeah, there's a cyclical relationship, and I guess you kind of need to maintain some of these things separately. But in terms of we're only ever going to load these values from the database at this point, having that cyclical relationship helps us ensure that we have a consistent instances as we're pulling them out of the database. Putting just an ID field in there means that you have to know that the ID field is supposed to correspond to a saved trainer. If you have an ID field for that. If you were to just change this to be string instead of trainer instance, you'd also have to make sure that that trainer name that you're passing exists. And the way that we're enforcing that ultimately is to accept instances of the trainer class as opposed to accepting instances of string. And so while there is like this circular relationship between these two classes, that's really fine as far as I'm concerned. And the benefit that we get from this is that we know that the value that's been passed to us is an instance of that other class.
Like when we are saving a Pokemon, it is the trainer that is doing it. Like it owns the Pokemon directly. So the trainer could just say like, this is my ID. Because like whenever we get a trainer, we're definitely going to have an ID. We never have a trainer without an ID in our code. So whenever we add a Pokemon, just like the trainer could say to this method, here's my ID, save this Pokemon to like whatever row is there in the data.
So I think your idea is okay. The main problem with that is that it's the controller's responsibility to make the instance of the Pokemon. And so that kind of forces the controller to have to know about things like, I need to pass the ID of the trainer to this thing. And that's achievable here within this very small contrived example, but in the bigger picture, like if you were to have a larger application, it might be more difficult to maintain that consistency between things. So
This point is fine.
typically I'm going to say that you would want to have class references to other classes as opposed to using your keys as a way to have references between classes. And having a recursive circular relationship between two classes is fine. Yeah. Any other questions? Yeah.
About the circular. So that
Well, memory, like a reference for objects. So I realize that none of you have taken a compilers class before, and none of you have, I don't know, has anybody actually built a virtual machine for an interpreter? So nobody's built a virtual machine for an interpreter in this room. Oh gosh, but you're taking Comp 2280 right now, and you've taken Comp 2400, so you know at least abstractly about the idea of pointers, yes? Okay, this is just a pointer. We're talking about 4 bytes. And if I were to use a number to represent this, it would just be 4 bytes. And if I were to use a string to represent this, it would actually be like 30 bytes because I'd actually have to put the entire string into this field. So in terms of memory, this circular reference, this is just like 2 classes having pointers at each other internally. Whereas with strings, you'd have to fully populate the entire string. You'd use more memory by using strings as opposed to pointers here. Yeah. That's a fair question, though. What is the graph structure here? And there really isn't going to be an impact on your memory usage as a result of that. All right. OK, so formalizing this. SQL injection is really about taking untrusted input and then using that to construct strings that represent queries or statements. Prepared statements are the way that we're getting around that. Prepared statements and parameterized queries, just to make the point, these are synonyms to each other for me. This is letting the database deal with it. And really, really formally, this is giving the database these 2 things as 2 physically separated pieces of information. We've got the query. We're giving the query to the database as one thing, and we're giving the data that the database should insert into that query as a separate thing. The database then is able to use that knowledge. This is data, and this is the actual executable query, and it's able to fully separate those. So it's able to then fill in the data to the prepared thing that we've got, or the statement, and it's never going to actually be interpreted as part of the query. So if I go back to the page that we've got here, this is actually the string that got inserted into the database. The database knew it was just a string to insert in the database and not meant to be used as part of the query itself because it never got put into the string by us. We didn't concatenate or build up a templated string using this value as part of that. All right. Let's assume that Walter managed to get our database. He was able to either get all of the data in the database by injecting queries into our queries, or he hit me over the head with a wrench and took the database, or convinced me to give him the database. One way that he's able to get all this database information by injecting queries is he was able to take advantage of the fact that SQL queries are often used to interact with the database itself. So we've seen all 4 of these different kinds of queries in SQL so far, but Walter would be able to use the select statement to get information from the database about the database itself. So databases often represent tables internally as table structures. One of the table structures that's in Postgres is called information schema, and this is available to you to run queries against. This is a table that you can make select statements on. And so Walter would be able to select queries from those tables in a structure that kind of looks like this. He would be able to inject SQL that's going to give him the ability to ask questions about the structure of the database. So information schema.columns here, this is a table that represents the names and types of columns that you have on a table in your database. He could inject this statement, and it would then possibly print out that information as part of a response. So in this case here, I'm selecting from the Pokemon table with these specific names. And in our TypeScript code, we've got this structure that says, well, this ID is a number, and this nickname is a string, and this HP is a number, and this trainer is a string. But Walter would be able to inject some query into this that says things like, what's the maximum length of this field? And if I had actually spelled this correctly, it would work, but I didn't spell it correctly, so it wouldn't work. But he'd be able to say things like, I want to select this character maximum length as ID. I want to select is nullable as HP. I want to select the table name as nickname, and I want to select the column name as trainer. And when this shows up in my page that lists my team of Pokemon, it's going to have like the list of Pokemon, but it's going to say things like the table's name is the nickname. So all the tables that it's able to get out of this are going to be the nicknames that show up. Is nullable, so this is a true or false value. It's going to show up there as like 1 or 0 to say that this is the current HP of this Pokemon. And so it's going to be tedious and painful to get all this information, but thankfully, not for us, but for Walter, there's tools like this. This is a tool that's called SQL Map. This doesn't work on the apps that we've built because we're not actually doing web interactions, but SQL Map is a tool that will effectively take an address in a web browser, and the addresses in web browsers will often have parts of the query that you want to run, and it will use that part of the address to then start doing SQL injection. And using that, it's able to then just get everything. It will give you the entire structure of the database, and it will give you the entire contents of the database. And in some cases, it can go so far as to get a shell running on that system so that you can start running commands on it. Thankfully, for us, our applications are not complicated enough to actually have that work. We could do it manually like this, but it's not going to be automated in the way that we could with SQL Map. But this takes us to the next part. Assuming that Walter was able to get this data out of the database, what kinds of data might be in our database? And then the questions that we're going to keep asking here are what might happen if Walter were to get access to that data? So I want you to think about this way more broadly than with the class example we've got. There's no sensitive information in this. This is just going to be like data that we have for our specific application, but more broadly, think about the apps that you have on your phone right now. What kinds of things might they be storing about you? I'm going to pop over to Mentimeter here. And I've got another question for you to start. My question for you is about this. I want to know if you know where this is. So these are some bears that are located in what appears to be a green kind of foresty area. Where are these bears? I'll give you about 5 seconds to answer this question. Okay, 5 more seconds. All right. Okay, I'm actually impressed. There is a pretty big cluster around where this is. Cluster number 4 here, or this cluster of 4, that's the airport. They're not at the airport. They're not on the runway in the airport. But this is in a big green area. And so I'm really delighted that there's lots of people kind of picking around here. And it is in and around this area. For your reference, this is in a place that's in Assiniboine Park. So if I zoom way in here at Assiniboine Park, we're not actually going to be able to get into there. Oh, we can actually get into there. That is, I'm not sure if I can see it from here. Yeah, it's right over here. There they are. Those are our little bears playing here. so that you can actually see where this is. This is the Leo Mull Sculpture Garden. This is in Assiniboine Park. There's a duck pond here. This is a constructed pond, but it's open right now for skating. There's no skate rental here. You have to bring your own skates, but it's a nice little place to go skating. And this park cafe has a window you could get some hot chocolate at. The Leo Mull Sculpture Garden. This is a really beautiful garden. If you get a chance to go through here in summer, it's a nice place to go and kind of like chill out. But the sculptures there are also really nice to have a look at. So congrats to these folks who are picking that same spot. And so I'm going to ask a question here for you just broadly. What kind of data might an application capture about users? All right, so usernames, emails, passwords, government IDs, full names, locations, yeah, birthday, name, face. This is an interesting thing that's come up very recently, I think, with like age verification stuff that's starting to show up in applications. Emails and passwords. Whether or not the password is compulsory in our specific project in this course, yeah, I'm confident that that will show up in lots of different apps. Yes, password will be compulsory for the implementation, and we will talk about that for sure on Thursday. It is not necessary to be included as part of your design for the first part of this, no, but it will be part of it for later. Your age, name, phone number, email address, financial information, browsing history, product preferences, willingness to live, that really brings us down here, but okay. IP addresses, IP banking info, Walter's secrets. Thankfully, Walter does not have any accounts on system, so I don't think that he would have any secrets. All right, this is great. Thank you for sharing all of this stuff. These are all really good examples of the kinds of things that an app might capture about us or about what we're kind of using this app for. I've got a variety of questions here that are now going to be related to the idea of what happens if that data gets out? What happens if Walter is able to like hit me over the head with a wrench and steal this data? Assuming that we're capturing names, what might happen if a partial name is leaked? What kind of outcomes might happen from that? So a partial name to me would be something like just your given name, or just your family name, or just initials, so not your complete name. Partially cooked, okay. Lots of nothings, a something, question mark, question mark, question mark, attacks from a stranger. Searching on a database, nothing. I think that nothing is probably the best possible outcome here. If you have a partial name, there's not really a lot that you can really do with that information. What about if a full name is leaked? So now I'm meaning to say your given name, your family name, and all of the other names that you have, all of your given names. Fully cooked and a chef emoji. So breaching privacy. This one is an excellent point here. Your identity could be cross-referenced with other publicly available information. And I'd like to give you an example of that as we proceed. But doxing, yes. They could find you on social media. Fully cooked. Identity theft. So I'm going to say that if your full name just by itself is leaked, that's not going to lead to identity theft necessarily. My name is on the internet in lots of different places, but I don't believe that my identity has been stolen yet. I don't believe it's been stolen yet. But identity theft is a reasonable thing. Lots of like cooked related stuff, okay? And OSINT tools to search you. OSINT, I don't know what the acronym stands for, but it's a security related thing. So ultimately, the thing I want to take from this is that more can happen than if it's just partial information that's leaked. We've got partial information here. Again, so address was one of the things that we had in our first list. What happens if a partial personal address is leaked? And so what I mean by that is things like just your street number, not your street name, just your street name, your postal code, but just your postal code, or part of a postal code, or just the city, or just the country.
Do they still know her name?
Do they still know your name? Maybe. Okay, this is getting a little too real now, but doxing, I think, is the main thing to start showing up here. Someone's going to come and steal the Bitcoin that's in your physical wallet. I thought the whole point of Bitcoin was that you didn't have to have it in your physical wallet. It's dangerous doxing. I think that's the main key here, is that we're going to start to get to this. But like, it's not fully. We don't fully have access to actual information about getting to, why does the cat have a wrench? I don't know. He doesn't have thumbs. I don't know how he's actually going to use the wrench. What could happen if a partial credit card number is leaked? So this might be, you'll often see when you're buying stuff and you say, please save my credit card, but it only shows you the last 4 digits. Or it has the full number, but it doesn't have that 3-digit number that's on the back of your card. Charges under $250, I actually don't know. Is that true? Can you buy things under $250 without that in an online transaction? Tap, I think, would work, but Tap is different. I think Tap would be different. You can buy flowers without a CVV. Okay. Nothing. Did I tape the wrench to the cat? Okay. Maybe cooked. They could guess the rest and steal your money. Fishing. Okay, so yeah.
And physically enter the number, like the numbers on a credit card, into a debit machine rather.
Okay, so you can actually type the numbers into a debit machine, maybe without those 3 digits. What if the whole thing is leaked? I don't know what is going on with my typing. I'm missing letters all over the place in these prompts today. Just a skull appears. Good enough. I think that answers the question adequately, yes. All your money is gone. Purchases are going to be made. You're done. You're broke. You're suddenly broke. You're cooked, fried, deep fried, and boiled. Unauthorized transactions. Is Walter evil? I would like to point you back at this picture here. Like, yeah, obviously Walter is evil. You're broke. Yeah. It's terrible things. Like, you're going to have lots of issues. In a lot of cases, like, credit card companies are willing to bail you out here. These are fraudulent transactions. Please reverse them. And that kind of goes back to the company that accepted that to happen in the first place. But yeah, there's going to be major issues with that. Here's the last thing I want you to give me some information about. So what could happen if a password is leaked? Identity theft, so kind of related to some of the other stuff, but the identity theft is the next one there. If I use the same password for all my things, everything is done for. I think that with no username, there's no threat is, I mean, that might be a reasonable thing to think about, but it's a lot more about this point here. If you use that same password for all of your things, and we've got your password and your username for one thing, now suddenly everything is done for. We're going to have access to all the other accounts that you might be using. Yeah, they steal all your Robux. They steal all your Robux. Don't reuse passwords. A good point to this one is use a password manager to manage your passwords and auto-generate your passwords as opposed to reusing the same password in lots and lots of places. All right, okay, so thank you. This kind of takes us to the end of that, and what this learning outcome is, this is kind of trying to address that learning outcome of, like, what are the kinds of things, what are the risks of having this data in the first place? And so,
You mentioned that using password manager, I think, but what if they hack into that? Like, now,
so using a password manager, I think I'd answer that question partly by this, but using a password manager will typically encrypt your data. So there's going to be a long key. If they get access to that key, there's a bigger problem, but there's lots of things that have gone wrong at that point. Yeah.
What would a testable question look like for that running account?
So kind of related to what we've just done, describe to me the kinds of things that an app might have and what are the risks associated with that. And all the answers that I saw, like joke answers aside, all the answers that I saw there were very reasonable things to say about what the outcomes or the consequences are of leaking that data. Okay, so assuming that Walter has gotten access to our data, Blue Team Walter needs to think in advance, and he needs to start thinking about making sure that the data that we have at rest, and so when I'm saying the words data at rest here, what I mean is the data in our database, the data that's just sitting there and being waited on to be queried or modified or accessed. We have to protect this data at rest. That can mean a few different things. That can mean things like anonymizing or de-identifying the data that we have. That means things like, well, I'll give examples of that in a moment, but where possible. So in some cases, certain applications absolutely need to have all of the data. They can't anonymize it or de-identify it. We can encrypt the data, again, kind of where possible. And for passwords specifically, we can use hashing to accomplish this task. Anonymizing or de-identifying data, very broadly, is the idea of taking data that would otherwise be able to specifically identify someone and just make it less precise. So a good example of that is going to be for things like taking names and kind of converting that into initials when you're representing that person in your actual data storage. So not using full names, but just using initials for that person. Another is related to addresses. So like, if you have a full address here, either just using postal codes or just using partial postal codes can you can still get some information about this, but it's not necessarily going to give a complete address for that specific person. The problem with this is that even with partial postal codes, you could still be able to identify things about people. So one example of that is we can take a look at the census here, and that can give us partial information. That can give us information even with just a partial postal code. So this is from Statistics Canada, and what I'm actually going to do here is I'm going to take a look at the postal code. This is for E2. This is the postal code for E2, where the computer science main office is. And if I look at this full postal code, the census will not give me any more information than to say, like, this is an area. It's not going to actually tell me anything about the people that live in that area. But if I give it just a partial postal code, it will give me information about the people that are in that area. If I know any additional information about the people in that area or the person that has that partial postal code, I'm going to go out on a guess and say that in my example here, Santa Claus is more than 100 years old. I'm going to guess that. If we take a look at the census and we scroll down here, 100 years and over, between men and women in this postal code area, there's only 5 people that live here. And we can start to piece together information about that specific person based on extra information that we have available about them. We can encrypt our data at rest. So if we have medical records or other kinds of information that requires us to keep things like personally identifiable information, we can encrypt the data. Encrypting the data is really about taking plain text. So this is a new keyword that I'm adding to you. I'm going to take the plain text. This is the address. This is the person's name, full name. This is their birth date. This is their public health insurance number. And transform that into random looking data, so ciphertext, using some kind of a key. So some kind of secret that you know and some kind of algorithm to make that transformation. And the idea is that we can turn that ciphertext back into plain text using the key, but the key is a secret that only either one person knows or is stored separately so that it's not going to be available to the person that has access to the database. Here, the general concept is if I've got this plain text hi and I have a key that's password 1, I'm going to use some kind of encryption algorithm, this arrow in this case, to transform that into something that looks like random looking data. And if I were to apply that key again, I would be able to get back the plain text that I'd originally put into the database in the first place. The problem with this is who owns this key? Where does this key actually go? If the key is in the database, if you put the key in the database, Walter got your database, and so he's going to be able to decrypt everything that you've got here. The database is probably not a good place to store this key. What if the key is in my head? So this is a secret that I've given. This is a password that I've used, for example. One thing can happen is that I forget it, and now I'm not able to recover the data. Another thing that can happen is that Walter hits me over the head with a wrench or threatens me with a wrench, and I just give up my password. The key often is not going to be in the database, and it's not going to be something that you let your user keep track of. It's going to be something that you store separately, but it's something you store somewhere. And in all cases here, this is going to be a related problem of if the key gets out, then your database is kind of available. For us in this course, I really want us to focus on the idea of password management and securely storing passwords. So, as I said last time, in a very hurried fashion, we're thinking about cryptographic hash functions. Have all of you taken Comp 2140 already? Has anybody not taken 2140? Okay, so everybody's taken 2140. When you've seen the word hash here, you're thinking about hash tables. The hash function that you're applying to that, taking these strings and converting them into a number. Conceptually, it's the same idea. I want to take a string input and I want to convert that into some kind of numeric or binary data. The difference between a hash table's hash function and a cryptographic hash function is that hash table hash functions try to distribute data uniformly across your table. I want to make sure that there are few collisions. I want to make sure that it's going to distribute data across all the elements that I have in this array. Cryptographic hash functions are going to do something similar to this, but the idea is I want to be able to make sure that it's going to be really hard to go backwards from this. So it's not necessarily going to be able to make it so that I can go from the data that I have back to the original value that I've got here. Another important difference between cryptographic hash functions and hash table hash functions is that small changes in the input are going to cause large changes in the output. So I want to show you this example. I'm going to go to my terminal here. I'm going to make a new terminal, and I'm going to run this command. You don't necessarily have to understand what the command is doing, but I'm going to say this, echo password1, and I'm going to pass this to another program that's called MD5sum. So this is taking the string password1 and it's giving it to a cryptographic hash calculation function. MD5 is one of these things. If I run this, I get as output this long string. This is my kind of arbitrary, random looking numeric data. If I change just one character here, it's a completely different string. There's no way to go back and say that these two things are even remotely close to each other based just on the outputs that we get from this hash function. This is not something that you care about with hash table hash functions. If I put password1 and password2 next to each other in my table, okay, I guess, it doesn't really matter. But for cryptographic hash functions, we want to make sure that they're very, very different from each other. The idea for us in this course is that you should not be storing passwords in plain text, but rather you should be storing the hash of the password. So given the password and a hash function, you should calculate that hash and store the result of the hash function and not the actual password itself. When you're trying to do a login operation, then it's not going to be asking if the password with that, if an account with that password exists, but rather the question you're wanting to ask here is, does an account with this hash exist? So given the password as input, recalculate that hash and then check to see if a username with that specific hash of the password exists in your database. There are a bunch of different hashing algorithms that you can use to calculate these hash values, like MD5, as I just showed you. You should not use MD5 though. You can have SHA-1. You shouldn't use SHA-1. Both of these are trivially breakable. So if I were to MD5 password decryption, decrypt is the wrong word here, but I don't know, I'll pick this one, sure. And I'm going to copy and paste this value here. And I'm going to decrypt it. And like within a second, it was able to figure out what the input was. SHA-1 is kind of the same thing. I'm going to try this. I didn't actually do this before class, so I don't know if this one's going to work. But if I put password 2 into this SHA-1 sum, which does the same thing, and I paste that into there, this one doesn't work. Because I'm doing MD5 only. That would be why. Crackstation.net. Sure, that looks like a reputable website. I want to decrypt. I'm going to put this SHA-1 hash in there, and it's able to do it in less than a second. It's able to get back that value that I put in there in the first place in less than a second. A better option is to use something called bcrypt. I'm going to recommend that you don't really use bcrypt. It is a reasonable way to do this. One of the things that this adds is something that's called a difficulty part. But the one I'm going to recommend that you use is PBKDF2, mainly because of how hard the acronym is to remember, but also because this is something that is actually recommended, as I mentioned last class, by places like the Government of Canada in their guidance on storing passwords at rest. This is an algorithm that they are strongly suggesting that you use for something like this. You should not implement this yourself. I absolutely do not want you to even begin to think about building your own cryptographic hash functions. Please do not implement this yourself. I wouldn't want to implement this myself because I'm going to guarantee that I will make mistakes when I try to implement this thing. Instead, you should use the Web Crypto API. And so I've put a link to this alongside the course notes for today, but this is part of the MDN documentation that describes how to use the Web Crypto API. And this examples link takes you to how you can write some code that will use the Web Crypto API to actually do the encryption stuff, do the hashing of your password. This is a good place for you to get information about how to do that. You do have to supply some information to this as part of getting this set up, and so I wanted to define these terms for you. First, you have to supply the underlying hash function that's going to be used by PBKDF2. I think I've said that correctly, PBKDF2. You have to supply this underlying hash function. This is something like SHA-256. This is something like SHA-1. This is something like MD5. I'm going to recommend that you use SHA-256 here. All you need to know about what this underlying hash function is that when I give it data, I get a string that looks like this ultimately. That's the only thing that I would care for you to know about this. You have to supply a salt. A salt is a known or fixed value. So this is not part of the password. Passwords themselves are secrets. This is something that the person who is trying to identify themselves is supposed to be the only thing that they know. A salt is a known or fixed value that you are generating. So this is not something that's generated by our user. This is something that you will fix. This can literally be a single hard-coded string that gets applied to every password that you're encrypting. Or it can be things like the username. So the username can be used as the salt. Part of the reason why I was able to choose random websites and like type in this hash code and very quickly get a response back is that there are databases that are filled with these strings. And there are databases that are filled with the string that was used to generate it. And they're hundreds of gigabytes in size. But it's a real quick lookup operation. The idea of having a salt is that if I were to say something like my username in front of password 2, that's not going to show up in a database because I've prefixed the string with this hard-coded salt value that I've got. Yeah.
Has it gotten a private key?
The salt is still not going to be a private anything. This could be public. You could publish this on your website. The important part is that to get this part of the password, you'd have to go through and recalculate that entire table structure because all of the hashes are going to be different because of the special string that you put in front of it. So you'll have to provide a salt. You'll also have to provide a number of iterations. This is the difficulty. One of the things that these two last hashing functions or hash families that I've described to you, so bcrypt and pbkdf2, is that they have this idea of difficulty. Difficulty really just means I'm going to run SHA-256 10,000 times. I'm going to take this string that you've given me as input and run SHA-256, and then run SHA-256 on the output of that, and then on the output of that, and on the output of that, and on the output of that 10,000 times over. For you, running this on your client's machine costs 0. For somebody that's trying to crack passwords, this is going to cost lots because they're trying to go through every possible password to generate all these hashes. The last thing that you need to pick is a length. This is the length of the hash that you want to get back out of the algorithm. And so this is the length of this. This is the length of the key that I want to get back from this thing. Again, you should not implement pbkdf2 yourself. You should not implement bcrypt yourself. You should not implement MD5 or SHA, whatever yourself. You should just use a library here. I'm going to give you a chance for questions in a moment, but this is kind of where we end security in this course. This is a rapid, I'm not going to dwell too much on this, but if you want to know more about it, there are several other courses that you can take. So Comp 3580 is a course that is, it's new this year. It's being offered, I think, right now in this term, but it will be offered again next year when you're taking 3,000 level courses. This is application security. And in application security, we're talking about things like some of the stuff that we've already started to do, but you're going to think about things like actual crypto stuff. You'll start to think about things like access control and authentication. So we're talking about authentication with usernames and passwords. Authorization is a different topic entirely. This is asking questions about what should you be allowed to do once you've identified yourself correctly. But then including things like software development stuff. So this part here, browser-based applications and SQL, this is the stuff that we're starting to think about in this course, but this will also include things like command line applications and other kinds of software that you'd be working with. Comp 4580 is an extension to that. Comp 4140 is Intro to Cryptography and Crypto Systems. This is where you'd actually implement things like MD5 yourself. This is where you'd actually implement SHA, and this is where you'd actually implement things like AES yourself. Some of the people in the department that you should know their names of if you're further interested in security stuff is Dr. Azadeh Tabiban. She's doing a lot of research on things like cloud computing. And so one of the things that she's been doing a lot is kind of related to keeping track of the changes that people are making to public cloud instances as they're working in their day-to-day work. And then when something bad happens, how do we take steps backwards to find out who caused that to happen in the first place? The other person that you should know about is, I'm really apologize to Sogand for this, but Dr. Sogand Sadragi, I'm really sorry, Sogand. She is also recently started in our department. And while her teaching interests here are networks and network-related stuff, it's also related to network security. And so she's another person that you should take a look at if you're kind of interested in this stuff outside of what we've talked about in this class so far. All right, at this point, you should be able to use tools such as prepared statements to prevent SQL injection attacks. So we'll talk about this on Thursday, but for your implementation of phase 2, you should expect that the graders are going to try and do SQL injection attacks on your applications. You should be able to begin to identify the kinds of risks associated with storing user data or information. So you should be able to identify, like, these are the kinds of data that I would possibly be storing in an application. These are the possible outcomes that would happen if that were to get leaked. The really big answer to this, by the way, before you leave is you just shouldn't store it at all if you don't need to. That's the best way to make sure that you have data security, is just not have it in the first place. But the very last part here is you should be able to securely represent and store credentials for authentication purposes. And so in the context of this course, that means you should be storing password hashes, and you should be calculating password hashes as part of the authentication process as opposed to storing plain text passwords. That's it for today. I hope that you all have a great rest of your day, and I will see you on Thursday. Bye, everybody.